Vertical speed indicator. Vertical speed indicator mainly gives us the information about rate of climb and rate of descent. Now, vertical speed indicator uses rate of change of static pressure. We can also call it as differential static pressure. Vertical speed indicator uses differential static pressure, whereas altimeter uses static pressure. Airspeed indicator uses dynamic pressure. VSI, vertical speed indicator, uses differential static pressure. Okay, here is the diagram, a sneak peek diagram of VSI. Here we have only static vent. Through static pipe, will be sending static pressure into the capsule, where some of the static pressure is sent outside of the capsule through a choke. And this is the leverage, and this is the pointer, climb or descent. So rate of climb and rate of descent were the information we are getting. Now what happens to the capsule if we climb? If we climb, the capsule contracts because more static pressure enters outside of the capsule through the choke. Less static pressure enters inside of the capsule. So the capsule contracts. During descent, it expands. Now, the vertical speed indicator contracts and expands. Due to this process, the pointer shows whether it is climbing or descending. So, what if we are traveling in a certain level? What if we are going? What if we are cruising? What if we are having straight or level flight? Then the pointer shows 0. So, when pressure inside the capsule is low, it contracts and shows climb. When the static pressure inside the capsule is low, then we are climbing. When the pressure inside the capsule is high, the capsule expands and it shows descent. Now here we have some errors in vertical speed indicator. It is blip, only blockage, leakage, sorry, not leakage, it's lag, blockage, lag, instrument and position. Now first of all, blockage. Underrates during both climb and descent, but in level flight it reads correct if static pipe is completely blocked. See, now blockage, we should consider whether it is completely blocked or partially blocked. If the static pipe is completely blocked, then during whether it is climbing or descending, it underrates the instrument underrates. But during a straight or level flight, it shows 0. But what if the static pipe is partially blocked? Static pipe is partially blocked. Then two low readings. What if choke is partially blocked? Then two high readings. If static pipe is partially blocked, we'll be getting low readings, under reading. If partially choke is blocked, then we'll be getting two high readings. Now lag error, of course we know. Then instrument error. Lag error is direct, instrument error is manufacturing defect, and position error. Due to incorrect position, we can get an error in the pressure difference. Now, for vertical speed indicator, it is very important to have a serviceability check. Serviceability check is done when the device is showing us plus or minus 200 feet per minute, or if it is between minus 20 to plus 50 degrees Celsius. Now what happens is, if we are climbing in some x flight level, x feet, but the instrument is showing us x plus 200 or x minus 200, then definitely we need to have a serviceability check for the instrument and the aircraft. Suppose we are having some y degrees Celsius outside the aircraft, but our instrument is showing y minus 20 either, or y plus 50, or in between any of these values, then definitely we should have a serviceability check. This is way too important for bits. So we'll be having serviceability check when the device shows plus or minus 200 feet or plus or minus 20 to plus 50 degrees Celsius. Now we have another kind of vertical speed indicator, that is instantaneous vertical speed indicator. Instantaneous vertical speed indicator does nothing, but it has no lag error. That is the only advantage we have with instantaneous VSI. It has a dashpot accelerometer and no lag. But there is a disadvantage with the instantaneous VSI, that is it is very sensitive. Since we have a small turn also, our instrument is going to show us wrong indications. That means the instrument is very sensitive. So this is the disadvantage we are having with instantaneous VSI, but it helps us without any lag. This is how VSI happens, and this is enough for the bits. Thank you.